Hello, my name is Kyle Pearson. I'm automating heating a house. So, a little background. My house uses central air, where basically it uses vents to heat the house, where basically some of these vents will pull in cold air as well as it will pull in cold air from the outside. It will heat it up, filter this air, and then send it back out through vents in every room. My house specifically uses a two-zone system where we have a thermostat on each floor that decides the temperature on the whole floor. Now, currently, the way my house is set up is there's a sensor in that thermostat that will detect the temperature in that room and will decide if the heater on the whole floor will be turned on or off. Where instead I want to use the temperature sensor in each room so each room is more accurately measured and the temperature is more accurate in each of these rooms instead of using one room to control the whole floor. This is done through the temperature sensors, as you can see in the top right. That is an example of one. Now, the location of these needs to be carefully placed, as if it is placed in an area with restricted airflow, in direct sunlight, or close to heat sources, it will not get an accurate gauge of the overall temperature in the room. The other control or sensor I want to use is the occupancy sensor. As with me and my sister being away at college, there is no need for rooms such as our bedrooms to be heated as much as the rest of the floor, as no one will be in these rooms. And then the controller type that is used is a thermostat, which is known as a limit control, as it limits the temperature in the rooms. And this is known as a bang-bang controller, as the system is either all the way on or all the way off. Now, in order to model the system, I estimated the heat gained from the heater and the heat loss from the walls. Now, this is divided up into three parts. This is the second floor, if there is an occupancy sensor in the room. This is the second floor if there is no occupancy sensor in the room. And then this is the first floor. Now, in order to calculate this whole system, overall the heat gain from the heater and heat loss from the walls had to be calculated, as there was no way to get an accurate measurement in my house. And then the temperature on any given day needed to be calculated, or which was done through just looking at the weather app and writing down the temperatures throughout the day. Now, this is what example simulation looks like on a relatively cold day. The first temperature is set to a slightly higher temp, as the people will be on this floor more often. I will go into more detail in these graphs later. Now, the first part of my system first checks the occupancy. If there's an occupancy in the room, where if no one is detected in the room, as you can see in the bottom right, the temperature in that room is lowered by 3 degrees, as there's no one in that room to need heat, so there's no reason to heat the room as much as the rest of the house. The next objective is to then check the temperature in the room, as this is called hysteresis in HVAC, where heaters can't be set at a perfect temperature, as it will cause it to constantly turn on and off, which is not good for longevity or efficiency of the heater. So in this case, it's set it to turn on until it's 2 degrees above the set temperature, and then it will turn off, and then it will turn back on when it's 2 degrees below the set temperature. This can be seen by these jagged lines. Every time it hits 2 degrees above the set temperature, it will turn off, then it will drop down to 2 degrees below the temperature and turn back on. And as you can see, the green circles, on a much colder day, like on the left side, it turns on and off a lot more often, whereas on the right, it turns on much less often due to it being warm outside, so much less heat is lost to the walls. And as you can see with those arrows in the middle left, when no one is in a room with an occupancy sensor, the room is cooler. Then when someone is in the room, it is set to the same temperature as the rest of the floor. In order to actually heat the room, the calculation done was heat gained by convection, as that is a type of energy that is gained in that room. Now, this is done by first finding the heater temperature, which in American households between 90 and 110 degrees Fahrenheit. This is then added to the room temperature, and then the heating change is calculated through this formula, and then depending on if the heater is on or off, either the heat is increased or there's no heat increased in these rooms. Then that gained heat is then subtracted or added to from heat lost to the outside, as the difference of that is the overall heat gained in the room. As you can see by that K on the bottom, that is the heat lost to the outside, which is calculated from those formulas you see on the left side. Then the change in heat is calculated through that top middle gain K, and then is integrated to get an actual temperature, not just the change of temperature, through that 1 over S, and then is outputted as the final temperature in the room. This process is repeated multiple times over until the temperature in the room is hot enough to where the heater can turn off. Overall concerns of this system is the overall cost, as adding all these sensors to all the rooms will be costly. And then the next one is overall with the occupation sensor, as how sensitive it is as to when it detects someone will need to be tested, as well as how long until it turns off and reads 0, aka it detects no one in the room, as overnight there may not be a lot of movement for it to detect. These are my sources. Thank you.